All right. So, hello and welcome everyone. So, we are live on this particular channel. Welcome back to this amazing platform of Tutee Learning. And today we're going to discuss about the chapter of area under the curve. Right. So, if you are new to this particular channel, please subscribe to the channel and hit the bell icon to never miss any upcoming notification that you're going to see on this particular channel. Okay. So, if you are someone who is preparing for the upcoming JEE mains and advanced examination in the year 2026, then you are basically on the right particular platform. And in this channel, every day you can see live lectures are basically there, not only on maths, but on chemistry and physics, which are basically helping you out for preparation of your upcoming JEE mains and advanced examination. So I am back again with this topic of area under the curve. So if you recall the last class, and I would recommend all of you that please go to the channel and you will find the playlist on area under the curve. So please watch the particular lecture before you are coming to watch this current lecture over here. All right. So with this particular thing, let's get started. And today we'll discuss about how we will solve different types of questions and what are the different principles that actually helps you to find out area and how you should make your integration much simpler to get the required area, right? So that is something we will talk in this particular lecture over here. All right. So if you recall in the last class, I have showed all of you that how can I simply find out the area under the ellipse, right? So I know the equation of an ellipse, and from there I found out the area of the ellipse just by using the property of something called as symmetricity, right? So in these different topics, as we go on with the curve sketching and plotting of the area under the curve, I will show you how you can use those basic facilities of curve sketching to actually get the meaningful data out of those particular ideas, right? So how you can apply the concepts of transformations of curve, how you can apply the ideas of integrals, or how you change the variables of the integrals, and what does the change of variable actually means when you do the curvature change, right? Or when you change the curve from one variable to another variable, what actually changes over there, we'll talk in this particular lecture, right? So let's get started, right? So when I talk about, when I generally talk about area under the curve, so when I talk about area under the curve, please note that area under the curve for some interval from a to b, is basically given as integration of that particular function from a to b fx dx, right? Right. Now please note that when I basically refer to area under the curve, I actually refer to the magnitude, right? I actually refer to the magnitude, right? So I don't care whether my function is negative or positive. That means whether this f of x is basically positive or negative in that particular interval from a to b, right? But what I am more concerned about is what is the magnitude. So what I do over here, I just use one mod over here. So I use a mod of f of x, and that basically thing gives me the area under the curve, right? Now, now, as you all know that now what is the basic principle for doing this is basically you have already studied that I can break the intervals of the integrals into some finite intervals such that it is continuous in its individual finite intervals, right? So that is something that I'm trying to explain you over here. So let's say if I have any complicated function, so maybe something like this. Let's say I have some graphical function, something like this. Okay. And let's say from A to B and B to C, right? So I have to get the area under the curve from A to C. Or let me also make some simple changes, or maybe like I can put a x-axis over here. Okay. I can put the x-axis over here. Okay, and let us say this is the origin, right? So some part of the area is below the x-axis and some part is above the x-axis, right? So if you observe, this is the part of the area below the x-axis and this is the part of the area above the x-axis, right? So if you note these things carefully, let's say the magnitude of this particular area is given as a1, and the magnitude of this particular area is given as A2, right? So when you carry out the integration from A to B, or sorry, I should probably write A to C, right? So when you carry out the integration from A to C for the function f of x dx, the result, when I do this definite integral, please note that since when I'm writing this definite integral, the result is basically equals to negative of a1 positive plus a2, right? So I will get this particular result over here, that is negative of a1, because that is basically lying below the x-axis, and a2 is lying above the x-axis, so it is positive a2, right? So therefore this will be my required definite integral, right? But when I actually implies the area under the curve, I should write the magnitude. So for a to c mod of f of x dx, if I've tried to find out this area, now when I do the mod or magnitude of it, the graphical transformation is as follows. So just repeat the part of the curvature, the part of the graph which is below the x-axis to its above x-axis. So just mirror it about this line y is equal to 0. So when you do that, then our required area is this particular thing. So that means this is going to be equal to a1 plus a2, right? So that is going to be the magnitude of the area. So please note that when I carry out the definite integral, I am not actually getting the area. I am actually getting the algebraic sum of the area, right? So this is a very important understanding, that when you calculate definite integral, you don't get the magnitude of the area. You rather get the algebraic area. I hope this is clear to all of you, right? So based on this, let's try to solve some questions. Okay, let me take some questions from the live chat. If you have any questions, please post that up on the live chat. Anyone, any questions up till here? So as we proceed with the question, we'll see how we can solve the question. First of all, when you try to solve questions of area under the curve, you have to first of all find out the curve, right? So it is always necessary that please try to plot the curve, and then you try to find out the area and bounded by the curve. Now sometimes it is also given in the question that the curve is very simple curve, like a linear curve, right? Or a simple linear curve, right? Or linear graph. So in that case, you actually can use the standard result of the area to find out that particular area, right? So we'll try to apply those particular basic things over here, and let's see how we can use those things in solving questions. Okay, so let me take a simple question. First of all, in the question it is mentioned, find the area under the curve y is equal to x plus 1 and mod of it. Okay, mod of x plus 1. So you have to find the area under the curve mod of x plus 1, okay, or from x equals to minus 4 to x equals to plus 2. So you have to find out the area bounded by this curve from x equals to minus 4 to x equals to 2. Now when I basically mean area, we also have to get a bounded region, right? If I am not able to get a bounded region, then how will I find out the area? The area will be technically infinity. So I also need to know that what is the bound of my curve. So it is mentioned in the problem, you have to find the area under this curve from x equal to 4 minus 4 to x equal to plus 4 with the x-axis, okay, with the x-axis. That is the complete question, okay. So to find that particular area that is bounded by this particular region. So before we start to solve this question, we have to first of all know how we can plot the curve of this particular function. Right. So if you look over here, it is a simple modulus function over here. So I'm going to use the results that we have already studied in our initial chapters of functions, right? So in functions, mod of x plus 1 can be given as x plus 1 for x greater than minus of 1 or maybe greater than equal to, and it is basically negative of x minus x plus 1 if x is less than minus 1, right? So I hope you know how to get these results, right? This is something simple as modulus function, as simple that, right? So if I try to draw the curve for it, the curve can be simply plotted as, so this will be minus 1, this will be 0. So at minus 1, the result is going to be equal to 0. So after the x greater than -1, it is basically a linear curve x plus 1, something like this, where at x equal to 1, its value is going to be 1. And it is going to, so we have to only find the area bounded between x equals to -4 to 2, right? So I will plot x equal to 2, where I'm getting the value as 3, right? And similarly, if you plot up till -4, this result is going to be like, so at -4, this result is again going to be equal to 3. So something curved like this, right? Some curve like this. Now, if I draw the required region, so the required region of the area is this particular region. Okay. Okay. So this is my required region, and therefore, now, so therefore, if I find the area from -4 to +2 for this function mod of x plus 1 dx, this result is simply the sum of these two areas, right? So which is simply a triangle, so I can find this area as half into so this particular length is going to be equal to 3, and this particular length is also going to be equal to 3. So 3 into 3 and 2 times of it. So this is going to be equal to 9 square units, right? So 9 square units is going to be the correct answer. So the curve mod of x plus 1 is occupying an area of 9 square units. I hope this is clear, right? And whenever you are writing this answer for, especially for board examination, please write it completely. Otherwise, teachers tend to deduct your marks, because when you are there asking about area, the units should also be mentioned over there, right? So please write your area answer carefully so that teachers cannot deduct any marks over there. Okay. I hope this question is clear. Is this question clear to all of you? Is this question clear to all of you? Santona Mania. Hello, sir. Yeah, hello. How to get maximum in these 5 months of JEE mains? What about you, sir? Your AIR. Orunavo Odhikari. Hello, sir. I'm new here. How are you? I'm good. Orunavo. Orunavo Odhikari. I'm good. Thanks for asking. How are you? Tejas, clear. Very good. Very good, Tejas. Okay, Santana, see, if you want to get maximum out in of for your JEE mains in these 5 months, okay, what you have to do is that please maintain a discipline. Okay, please maintain discipline, that you are regularly attending the lectures, you are basically taking classes every day, you are solving examples, you are solving test papers, so that is actually will help you to get maximum in 5 months. Okay, and if you want to get more benefits and if you want to prepare especially for your 5 month preparation, please contact us on this particular number. Okay, I will guide you more better in this particular on this number. Okay, so please contact on this particular number. Okay, please note this number. Okay, 833-98-27528. Tejas, advice for you. Okay, see, I can give you one advice is that please be curious. Okay, just be curious to learn more and more. Okay, the more you are being curious, the more it basically shows that you are basically interested towards this particular subjects. Okay, and once you get interested towards the subject, clearing any form of examination will be just a piece of cake. Okay, I'm right now solving JEE means previous year questions. Very good, Tejas. Okay, so please note down this number and contact us on this number so that I can guide you in a more better way. Okay, so actually you need some guidance and one-on-one classes. So please contact us on the number and take our online one-on-one classes so that I can help you out in a much better way. Okay, is it clear to all of you? Shall we proceed? All right, so let's proceed with the next problem. The next problem is basically here in the question it is said that you have a curve like x square minus x square minus y square is equal to a square. Okay, so there is a hyperbola which is given as x square minus y square is equal to a square. So you have to find the area bounded by this hyperbola between x equals to a to x equals to 2a. Okay, so in between the x equal to a and x equal to 2a, you have to find what is the area bounded by this hyperbola between these two regions, right? So let's try to see, first of all, how do we actually plot a hyperbola, right? Now again, let's analyze the question again carefully. So if you analyze the question, okay, if you analyze the question, and first of all, if you assume this is some function of x and y, like x square minus y square minus a square, what you can note is that if you replace the function with in place of x, if you put minus of x, it remains the same function. And similarly, in place of y, if you put minus of y, it is again remains the same function. So that basically shows that there is a symmetricity, that there is a symmetry, okay, symmetry about x and y axis, okay. So there is a symmetry about x and y axis. So we are going to use that particular topic of symmetricity in getting out the ultimate area, okay. So we're going to use this particular idea of symmetricity to get the answer in a much easier step. Is it clear? Can anybody of you tell me the answer? Tejas, can you try to tell me the answer? Yes, anyone? Do you have any answer so far? Okay, so I see there is no one is giving the answer. So let's proceed. Okay, so if I try to first of all draw the curve or draw this hyperbola, so I have already shown you that how does a hyperbola looks like. So it starts at point A over here, and it's something like this. Similarly, minus a comma 0 and a comma 0 are the two vertices, like this, right? Now I have to find out the area that is between x equals to a and x equals to 2a, right? X equals to a and x equals to 2a. Okay, so therefore ultimately I have to find out this particular area. Okay, so if you note carefully, so I have to find out this particular area, right? So in order to find out this particular area, I can use a symmetricity. Since it is symmetric about the x-axis and the y-axis, y-axis symmetricity is not that important in this particular part, but x-axis symmetricity is important, right? So what I can do, I can try to find out this particular area. I can try to find out this particular area, and then I multiply by 2, right? So the entire area will be 2 times of integral going from a to 2a, for this upper part, So this is basically, so y square will be equals to a square minus x square. Am I correct? No, right? Yeah, it should be x square minus a square, right? X square minus a square. Therefore, y is basically square root of x square minus a square, right? So if I do this integration, this will be, sorry, y x square minus a square and square root of that, right? And dx over here. So I'm taking the positive one, so doesn't matter. So I'm not using the plus minus sign over here. Now please try to solve out this integration. You have already studied about this integration, so I know how easy this integration is to, right? So if you just apply the formula, the integration answer is basically x by 2 square root of x square minus a square minus of a by 2, and then we have natural log of x plus square root of x square minus a square, right? And this will be the result, but note that the limit of the x is going from a to 2a, right? So if I put these values over here and I solve for it, finally the answer that I'm going to get is basically 2a square root 3 minus a square log of 2 plus root 3 minus a square log of 2 plus root 3 square units, okay? So this is going to be the ultimate answer. So the ultimate area is going to be this particular answer. Can you please check, any one of you, that are you getting this result or not? Tejas, yeah, 2a square root 3 minus a square log of 2 plus root 3. Very good, Tejas, very good. Yes, sir, I have learnt integration and limit. Very good, Tejas. Excellent, Tejas. A big shout out for Tejas. Amazing. Okay. So if this question is clear, I hope this question is clear for all of you, right? Very good. So let's now, if this question is clear, then we can proceed with the next problem as well. So in this class, we are going to solve some question, and now I'm going to take that idea that what happens when I give you two curves, and what is how to find out the area that is enclosed in the intersection of two common curves, like, or two curves. So let me give you this question. So the question is fairly simple. So the question says that you have to find the area common to the parabola area common to the parabola 5x squared is equal to y and 2x squared is equal to y minus 9. So you have to find out the area which is common to this both the parabolas. Okay, so to find out the area which is common to this both parabolas. Okay, please tell me what are you getting as the answer. Try to solve this question. Take your time. Take your time and try to tell me the answer. Okay, what is the area which is common to these parabolas? Okay, so if you are new to this particular curvature plotting, I am trying to help you out, showing you how the curves can be plotted. Okay, just it's fairly simple. So for the first curve, x square is equal to y upon 5, so which is something like this, right? Something like this. And on the second curve, which is equal to x square, or y is equal to x square plus 9, it is going to start at the vertex is going to be 0, 9. Okay, so this is going to be something like this. The curve, this particular ends, or it will be higher. Okay, so if I talk about the common area, so this is the common area that in the question you are basically going to find it out. Okay, so if you again see over here, what you can observe is that this particular curve, if you put in place of x, if you put minus of x, it is symmetric, right? So it is symmetric about the y-axis, right? So you can see and you can find this result very easily that it is symmetric about the y-axis. So in such examples where figure is most essential thing, so without figure it just becomes difficult to judge whether y1 to be subtracted from y2 or not, right? So generally when we solve questions for the area bounded by two curves, now the general idea, fundamental idea is that you find out this particular area, you find out the area bounded by this particular curvature over here, and then you find out the upper curvature and then you subtract it, right? So that is a basic idea over here. So what we do is that we try to find out this kinds of thing by doing y1 minus y2 and mod of it and then dx. Okay, so this actually gives you the area in between two curves. Okay, so area between two curves. Okay, so if I talk about area in between the two curves, it is basically given by this particular form over here. I hope this is clear, right? So when I have to find out the area in between the two curves, I have to subtract y1 from y2 and take a mod of it. But when I don't draw the figure, it becomes difficult to predict whether y1 should be subtracted or y2 should be subtracted from y1, right? So when we draw the figure, it is very clear that let us call this is y2, this bigger one is y2 and the smaller one as y1. So therefore in this question we have to subtract y2 from y1 from y2. Am I saying the right thing? Sorry, y2 from y1, right? That means it should be y2 minus y1. That should be the correct one, right? So y1 is subtracted from y2. Okay. All right. So if you please try to solve the question, I have already set up the ideas. Now you will be able to solve the question easily. 12 root 3. Let me check. Let me check the answer. Yes, very good. Very good, Tejas. 12 root 3 is the correct answer. Very good, Tejas. Okay. 12 root 3 is the correct answer. Very good. 12 root 3 square units is going to be the correct answer. Are you all getting the same answer? Please let me know. Very good, Tejas. Excellent. Excellent, Tejas. Your preparation, I think it's very nice, right? Very good, Tejas. So, is every one of you getting the same answer as Tejas? Please let me know in the live chat. So, Tejas, for you, I have another question. This is a question from the JEE paper only as well. Okay. So, please try to find out. Meanwhile, other keep on working on this question. I don't want teachers to sit idle in the class. So meanwhile, you keep on solving. Okay. Try to find out the area bounded by this curve y is equal to x to the power 4, y is equal to x to the power 4 minus x square. Okay. And the x-axis. Okay. And y is equal to 0 line. So try to find out the area that is bounded by this curve and the x-axis. Okay. Also within the two minimas of this curve. Okay. Within the two minimas. Okay. You have to find the area bounded by this curve within the two minimas. Okay. Within the two minima ordinates. Okay. Within the ordinates of the two minimas of this curve. Y is equal to f of x. Okay, so let's call this f of x curve, right? So to find out the area that is bounded by this curve and x-axis and the two minimas ordinates of this particular curve. Okay, so to first of all find out the minima, and then to work for the drawing the curve of this particular function, and then you have to tell me what is the required area. Okay, I hope this question is clear to you. Is this question clear? Can I get under 10K rank? Okay, 10,000, right? Yeah, sure, teachers. Why not? Under 100 also you can get it, okay? Why under 10,000? Why not under 100? That's also another interesting question. Okay. I think this green pen is not that clearly visible on the blackboard, so rather I will try to write it in different colors, okay? So I will not use this green color. Okay. I'll change the color of this pen. I will use some better colors, like something like this. Okay. I think it's the same. Please solve this question. Please solve this question. Yeah, this is a better color. Yeah. So please try to solve this question and tell me the answer. I hope every one of you are getting how we are calculating this area, right? You just have to find out y2 minus y1 and then take the integration within the limits, right? Also, please find out this particular form, okay? So just you integrate from 0 to this particular x1, okay? So if you integrate from that particular x1 and multiply by 2, you're going to get the result because it is symmetric about the y-axis, right? 7 upon 120. Very good. Very good. The ultimate answer for this particular problem is going to be 7 over 120, right? I hope Tejas, you are not basically, you're also working out on the question, okay? Maybe you have already worked on this question, because it might also happen that you have already solved this type of question. So it may be there that you have know the answer and you're telling that, okay? But still, if you are able to solve this question in such a short time, yes, this is a JEE previous year question. Yes, correct. Correct, Tejas. You are right. All right. So I hope this session is clear to all of you. Right. Now I would like to conclude the session with certain homework, okay? With certain homework problems. And in our upcoming classes, we will try to solve more and more problems as well, okay? So the homework problem that I want to actually give you is something also known as parametric curves, okay? So I will discuss about what is a parametric curve, right? So what is a parametric curve? I will talk about it. So parametric curve is basically a curve like, so when we generally draw any curve like y is equal to f of x, so here my independent variable is x and dependent variable is y, right? But what if I associate one more independent variable and say as t, and I associate x and y are both dependent variables. So let's say I have x as some function of t and my y is also some function of t, right? So in this case, when I have this kind of formulation of functions and I put it in the curve equation, then this kind of formulation is basically known as the parametric curve. Okay, or this is something also known as the parametric representation of the curve, right? So if you understand this particular topic, then please try to solve this question as a homework problem. Find the area bounded by the curve x equals to 80 square and y is equal to 280. Okay, find the area bounded by this curve x equals to 80 square. Okay, x equals to 80 square and y equals to 280, right? So from here eliminate the parameter t and then you get the equation in x and y, right? So that's the simplest thing, right? And you have to find out this area. So since I am telling you the parameter is t, so in between 1 to t is equal to 2. Okay, so to find out this particular area from t is equal to 1 to t is equal to 2. Okay, so please try to solve this question and let me know the answer in the comment section of this particular lecture. Okay, so once this class is over, please try to solve this question and tell me the answer for this question. Okay, so in the next class I'm going to discuss that what does this parametric equation actually refer to, right? So if you can also do it by yourself, and you must have probably know that this parametric form is nothing but parabola, right? So if you still have any question, give a try. I can discuss in the next class. Okay, I hope Tejas you already got the answer to it, right? I have solved this already. Very good. Any book recommendation? I can recommend you a lot of books. Okay, especially for integral calculus, I can recommend uh, quite a few nice books. Okay, but those will be general book. Okay, and if you refer to any Indian author, I would refer you to the book of written by Professor R.K. Jain. Okay, there is a good book on advanced calculus written by Professor R.K. Jain. So you can refer to that book on R.K. Jain. Okay, and if you want to follow more integral calculus, I can show you the book as well. Okay, let me give me some time. I will show you the book. Maybe I have the book actually. Okay, so you can also follow these two books by N. Picasso. Okay, he's a Russian mathematician, and I hope you can see the book. Can you see the book, Tejas? Can you see the book over here? I think it's difficult to show the book, right? When I have this green screen thing and all, right? Because it is not going to capture that so nicely. So these are the two sets of books that you can follow. Okay, this is volume 1 and volume 2 by differential and integral calculus by N. Picasso. Okay, so he's a Russian mathematician, and it is a book published in Moscow and translated in English from Russian. So you can follow his book, and the publisher is basically CBS publication. Okay, this is a very nice book. Okay, and it can teach you a lot of basics on differential and integral calculus. Okay, so this is a book that I can refer. I can recommend all of you about learning mathematics and you want to go deep into calculus. These are the two good books that you can start with it. Okay, and then you can move with real analysis and all those topics. Okay, but first of all, please try to solve these two books and then you can move forward with the other set of books, right? Is that clear to all of you? Is that clear? My camera is not that good to actually perceive the difference between me and the books. Okay, so because sometimes when you put the green screen thing in, so this actually happens. Okay, so please take a note of these two books. Okay, and if you are able to purchase these books, these are fairly like very cheap books. Okay, I think it's hardly cost around like 200. Okay, so you can get it from the market or from the local market, and you can refer to these books. And once you are done with these books, I can refer you some other books especially for practice. Okay, and as you are getting more and more interested, then I can refer you further high level textbook as well. Okay, which are basically good for learning mathematics. Okay, now please note that once you're actually learning mathematics, don't Sir, PDF, I don't think it is available easily on the web. Maybe you can search it up, okay, but hardly it will cost around like 200 rupees, okay. So I think it's better to buy this book in physical copy, because this is a very nice book, okay. And trust me, this is not only for your, see, JEE things and all things are very specialized, but if you really want to learn mathematics, solving one or two questions or standard templates of question actually doesn't make you a good mathematician, okay. So solving this integral question which is already there as a form of a template in the book doesn't makes you good in mathematics, okay. Is that clear, Tejas? I think you will be able to resonate with my sayings, because when you're solving question for JEE, there is a standard set of questions that you need to prepare and solve, right? So once you know the template of questions, or once you know how the questions, how the types of questions are basically being asked, you can apply the same concept to any questions over there, right? But in order to learn mathematics from the scratch, you need to know that what is the basic things that is going on, okay? BSc in mathematics is my dream. It's actually BSc mathematics, right? BSc is like old. It's not basically there. I think in India also, people are offering, universities are offering BS degree as well, right? Bachelor's of Science in Mathematics. Very good. Yeah, that's a great thing. Okay, maybe then I will have some recommendation for some best universities for, especially for mathematics. Okay, I would say you can try for the ISI examination. Okay, I will write it over here. ISI examination, and please try to go to ISI Kolkata. Okay, it is one of the best mathematical institutes for mathematics and statistics. And apart from that, this CMI is also a very good institute, which is basically especially for mathematics. Okay, there is Chennai Mathematical Institute. Okay, so these are the two good institutes that you can follow if you are very much interested in mathematics. Okay, and if you are more into probability statistics, statistical mechanics, and stochastics processes and dynamical theories, and those things, then I would refer you can go to ISI. Okay, and if you are interested more into the real analysis, all those things, you can prefer going to combinatorics, that is basically a subject of partition theory, or real analysis, you can go to CMI. And if not that, you can also try for examination like ISARs. Okay, so in ISAR also, you can pursue your interest in mathematics as well, right? So here the degree is more oriented towards the research. Okay, so they offer you BSMS combined degree. Okay, so once you get an admission, it is basically a 5-year program. Okay, so once you get an admission, you don't actually have an admission into a particular branch, right? So you are basically admitted into a common curriculum, right, where every one of the people are basically learning up the same thing, right? But once you go ahead in life, so once the first year is over, and at the time, based on your GPA and scores, you can basically given the option to choose which subject you want to go for it, right? So ISAR are also good for it. Maybe ISAR Mohali, ISAR Pune, ISAR Kolkata. Okay, they are the like good top ISARs, right? Harvard's and MIT. For Harvard's and MIT, I'm curious that how we'll be able to obtain the study permit. Okay, because these days, the president of USA is not that good with the Indian students. Okay, so he's basically not offering study permit that easily. So maybe in order to clear the visa thing and all, and to give the interviews for visa and all, I don't think you will be able to get the study permit that easily. So maybe then Harvard's and MIT would not be a good choice. Okay, but for Harvard and MIT, yes, they are also good. But MIT is not that good for like Harvard's. Okay, MIT, okay, for mathematics is good. Like specifically applied mathematics, MIT is wonderful. But if you are interested in mathematics, I would say you can try for Princeton University. Yeah, Oxford and Cambridge, they are the best. Okay, maybe for mathematics, especially if you are interested in pure mathematics, then I would refer Oxford. Okay. Okay. So yeah, we can also talk about this in further classes, but Tejas, please subscribe to the channel, okay? And you can also contact me on this particular number, okay? Please connect on me on this number. I can give you more ideas on how you can proceed with your preparation so that you can get an entrant into USA, okay? Sir, 9th में हूँ, poor 11th physics AI या half chemistry हो गया, maths नहीं हो रहा. Sir, স্যার আমি 9-এ পুরো 11th ফিজিক্স হাফ কেমিস্ট্রি হয়ে গেছে, ম্যাথটা হচ্ছে না. Gamers YT, okay. See, if you're in class 9, first of all, I hope your class 9 syllabus preparation is going good, okay. And if you're interested in physics and mathematics, chemistry, keep on studying, okay. Please contact on this number, and take the online batches. Okay, then you can be able to do mathematics much better. Okay, so Gamer YT, please contact me on this number and get the access of the one-on-one online classes. Tejas, not in pure mathematics. Okay, then you can go for, okay, so if you want to do in applied mathematics, yes, that is quite good one also, right? Okay, so keep on studying and please contact us on this particular number and get one-on-one online classes so that I can help you out in much further and in a better manner, right? So in YouTube, you can see like there are a lot of students who are basically studying up and some students are not actually. So it is also for free, but in YouTube there is some restriction, right? I cannot do everything as my part, right? So if you take out the one-on-one classes, there I have more flexibility and control over you, right? I can guide you in a proper channelized manner so that I can show you that this is the way you have to solve the questions. Now once you're done with this question, what's next to be done, right? So I can guide you in a proper way, right? So please take these online one-on-one classes so that you can know, and it's a very minimal fees, right? So at very basic fees, you can basically afford those classes for each classes, right? So with this, I thanks all of you for your attention.